my presentation. Right?
Yes, your presentation. Your second.
Okay, sorry. So, did you hear me? Hello, everyone. I'm voraphan and also my co-author, Takashi Ota. So we are from Tokyo University of Technology. And today we are honored to present our research, the interactive pavement, moving spatial surface to dynamically convey the information. So from the overview of our interactive pavement. So the idea of the design of the interactive pavement which convey information to a person feet by preparing the mechanism beneath the pavement surface to create a subwave like a movement. So in this project, we present the various of the physical wave patterns and we demonstrate the example of the scenarios and be applied with the concept. So this is the figure of the idea of the interactive pavement in an environment. So let's get started with the background. So the emerging information technology such as artificial intelligence and Internet of Things are on the rise. So it takes advantage of our spontaneous spatial reasoning skill and ability to haptic interact with the surrounding environment. So there are a lot of useful digital functions, but people use them mostly by their smartphone. However, this is useful if the person has a smartphone with them, but without it, they cannot do nothing. So in this research, we alike to the Society 5, the emerging from of the society is characterized as a creative society that employ the digital transformation into an environment. So this is our motivation. The first, providing the concept of integrating of the digital function into an environment. And second, designing the interactive pavement which can convey the information to a person feet. And the last, examining the validity of the concept of the interactive pavement. So in this project, we present some of the possible application scenarios using this interactive pavement as follows. At the first, it can be used for guiding, changing of the traffic light can be notified, especially the visually impaired and try crossing. It can be used to guide the people in particular direction while they are walking. And second, to notify, using the pavement is equipped with a sensor to detect the car. It can be used to generate a warning to notify the person of the unknown danger or the dangerous surrounded them. So, and the last one, this can be useful for attracting people attention or something placed along the pavement. This would be possible to create it, the wave like a triple for intriguing the people. So in the design specifications part, this project, the Pavement is expected to be able to convey the variety of the information by a different wave pattern formed on the surface. So now in this project, we sample the basic pattern. The first, we call one direction pattern. With a varying speed and interval can indicate the movement in the particular direction, for example, in the forward, backward, left and right direction to the user foot and feet. And the second, we call the circular pattern. So this pattern could be one of expanding circle from the certain point. So as a varying propagating speed, area, and interval speed, this pattern can be overlaid to express multiple types of information simultaneously. So furthermore, each pattern can express a different type of the information by itself, depending on the context which it apply at the scenario that we present. And the prototype part, implementation for the hardware part. So we first implemented our interactive pavement prototype. So it was designed to able to convey the information to the foot or feet perception. Using the tie and the 3D print actuator for driving them, so the system could deploy the instruments such as motorized rod array to move the tie for fully conveying information by the physical movement in the form of the wave pattern that we designed. So the servo motor and the 3D print actuator were used to move the rod. In the vertical length of the rod was 20 centimeters. So we were constrained by the dimension of the 3D print actuator to achieve the minimum distance between each of them. So the actuator were placed in the square grid with a spacing of the 8 centimeters in each rod of the conversion process in this prototype. So we use Arduino board to power 16 rods. And this approach was for the system to achieve the web pattern to convey information to the user as our first prototype. So this is a software control. So the tie were controlled by the servo motor rods, which were controlled by an Arduino. Each tie has a microcontroller that regulates the servo motor beneath and be sent the data from the computer. So the software update and communicate with the microcontroller by selecting the function of each wave pattern that we set. So we store the order of the functions in the array function of the delay time and degrees value of each motor individually and correspond to each wave pattern, and each tie then loop through the stage of processing of the selected wave pattern and the tie rendering the cycle. So next is a video. Yes, so previously is a prototype demonstration. So next, the preliminary performance evaluation. So we evaluated the position error of the pavement. We performed the test of the 100 times to determine the accuracy rate of each model. Considering of the result of the accuracy rate, we confirm that the use of the Arduino can be controlled. The servo model is successfully, which can be increase or rise up the time of the 16 rods. So the user can identify the direction of the pavement and the strength. The user can lightly touch on the surface, but however, it's a simple prototype of the structure is not robust enough because this is our first prototype. We just want to flexible the concept to convey the information at first. So we will use the user lightly touch on the surface, not like fully step on it. So we show about the error precision at the next. So we also evaluated the position error of the pavement, and so we display the two-wave pattern in the first, the trend and the right direction of the one direction pattern. So the results show that the average perception error range of is around 0.5 millimeter in the both of wave directions, forward and right. So the error are much smaller than the rod pi, and the result indicate that the interactive pavement succeeded in the presenting in the term of the site. And this is a user study part. So we examine the behavior of the novice user of the device for the usability test. In this experiment, we involved 20 participants, 6 females and 14 male, average age like 23 years old. So note that these participants were the sneakers in condition 3 and 4. So we categorize the subject behavior into the 4 categories. The first, user touched the pavement with the bare foot. And the second, a user touched the pavement with the bare feet. And the third, user touched the pavement with one foot while wearing shoes. And the fourth, touched the pavement with their feet while wearing shoes. So as you can see from the result, as we perform the forward and the right direction to the participant, the experiment results show the correct answer rate was higher in 2 foot and the condition than the 1 foot condition. So because the perception of the surface of the barefoot and the feet, so they can perceive more the information from the both foot. So we confirm that the prototype can convey the information by producing the physical movement to the user. And the second, the interactive pavement around the nature interaction using foot and feet. And the last one is the most of the participants can recognize the wave pattern without any instructions. And the thing that we need to study further, the first, the mechanisms are not robust enough to support the body weight because it's from the 3D printer material. At first, we try to prove the concept at first, and then in the future work we propose to let the user standing on it and expand in the large side. And the last one that we want to study further, the prototype has a limitation in terms of the system to convey the information from the resolution of the rod in the vertical and the horizontal axis that make the resolution is limited and fixed. So the rod in this project is as a fix, cannot adjust anything. And the second is the size of the tie. The tie has 3 by 3 inches, so it's very large to attach to the foot and feet. So, for example, like 1 foot can perceive like only 2 tires. So the information is quite very small. So we propose to the next prototype to minimize the tie. And the next, the surface is not smooth. Because the surface is not smooth, the participant cannot feel the edge properly. That can make some mistake to the user. So as a future challenge, we propose a new mechanical design. So we hope to create the expanded or larger and robust surfaces, and that people can standing on it, and also the new design of the web pattern to create the various information for multiple users. And we propose to expand the application as we propose, like for guiding, notifying, and intriguing, as for the practical application to be used in the real environment. And in this project would allow the product planner and the city planner to redesign the product and city using this device. So that's all for our presentation. Thank you so much.
Okay, your presentation. Does anyone have any questions and comments? Oh. Yes. Okay.
I tried to use.
Oh, I can hear.
Okay. So could you show me the slide of evaluation?
Okay. For the user,
Yeah. So you said 6 female and 14 males. So is there any difference between male and female?
so actually we like had limitation for this condition because we cannot like judge that which gender is the best perception, because it's not equally. So we propose to study more to prepare the same number of the gender, yeah, to show the feasibility. But now we didn't find out about the difference of the age yet. Yeah.
How about the size of foot?
So the foot. So all the gender feel the information from the surface using their feet, like both foot. In even bare feet or bare feet wearing shoes, so they can feel that even the male or female. Yes.
Okay, so and I have one more very easy question. So you use Arduino device, right?
Yes.
So how many Arduino device?
Ah.
16 or more or less?
We use like one Arduino to control like 16 servo motor, like a motor.
One Arduino for 16 model.
Yes, so
Okay. Okay.
thank you so much. Do you have any question?
Okay.
Okay.
Yes, I have a question about this evaluation, this page. So I think your tile is very big, 3 inch, 3 by 3 inch by 3 inch.
Yes.
I think yes, maybe I should categorize the result by foot size. So my foot size is big, and maybe some people's foot size is small. So 3 inches, maybe it's one our foot width is small or
yes.
yes. So I think so categorize by foot size or more small tile you need. Yes, and
Yeah.
I think why you use tile cardboard? Why use cardboard for tiles? I think you make other parts. You use a 3D printer. Why you use make tiles with 3D printer?
So this is our very new project for the prototype. So this project, we just want to confirm the idea at first, but not in the mechanism. But now we are preparing the next prototype using like stronger, like smooth surface, and then we change the rod to push the surface up. So it's smaller resolution. So we're gonna develop it further.
Okay, thank you.
Thank you so much.
And anyone has a question? Okay. Yes. Next presentation.